Welcome to the Internet of Things Made Simple. I'm Larry Bohumer. Today's topic came as a request, actually, and we're going to be looking at how do you decide what technology to use for your IoT device. I do apologize in advance. Going to be a touch long with this post, but there was so much information I wanted to get in. I wanted to make sure I covered everything thoroughly. There's two decisions you have to make when you decide to add IoT to your product. And I'm not sure what order you want to decide them in, but I'm going to list them this way. The first you have to decide is whether you build, buy, or integrate. And that's whether you build your own device from scratch, do you buy an IoT-based device, or do you integrate IoT-based technology into your solution. Based on the popularity of a blog post that I did, I'm going to be doing this one next. So episode 3. Today we're going to be focusing on, though, the other question you have to answer, and that's what technology do I use to connect my device? We're going to list off 9 different choices. Depending on what you're doing, each of them might be a viable option and a very great choice. As well, each of them could be a horrible choice, depending on what you're doing. Out of the 9 options, 4 of them are non-cellular based, and some of them might not even be thought of as ways to connect IoT devices, and the remaining 5 are cellular networks that are either available today or will be soon. Some of these choices are available now, other ones are just in their infancy, and other ones are coming out in the next year or so, and we'll make sure we highlight that. When we come back, we're going to talk about the 4 non-cellular options that you have for connecting your devices. Back in 5 seconds. Okay, so before we get into the actual technologies, I wanted to cover a few housekeeping items. There are a number of reasons why you might pick a certain technology, and there's going to be an awful lot of overlap between the 9 different technologies that I'm going to mention. And actually, I'm not even including Bluetooth, so it could be 10. So why would you pick one over another? It's probably for a few different reasons. Perhaps it's what you know. If you've been using a certain technology for 10 years and you've enjoyed the experience of it, you haven't had any major issues, maybe you just don't bother to change. And there's nothing wrong with that. It could also be that a technology is the industry standard that you use, and it could even be mandated by a government agency, as an example. The last area is biased. Some people are quite simply biased for or against certain technologies. It's important to remember that because, as I mentioned, many of the applications that you're deploying IoT for could actually use just about all of these technologies and possibly could use multiple ones depending on where and how the deployment is being done. The last housekeeping item is that there are definitely more technical explanations out there than I'm about to give you. If that's what you're looking for, this probably isn't the right place for you to get the information from. Instead, we're going to focus on things like business cases and practical ways that the technology is being used. So the first technology is something that many of us have used for years, and something that some of us use today, depending on how you have your network set up. And that's a wired connection, such as an Ethernet. It has a lot of things going for it. It's proven reliable. It's used in some of the most mission-critical applications on the planet. And depending on what equipment you have at your home, it's probably pretty widely available as well. Another great benefit to using a wired connection is that most plans available from the telecoms offer unlimited use. So you can go ahead and transmit 7x24 video, and you still might not even approach the cap on many of these plans. So it's ideal for high traffic as well as for applications that need low latency. And for those of you who've forgotten what latency is, it's the time it takes for a piece of data to go around the network. So if you want to look at it this way, here's a joke I've used a few times. My latency for getting ice cream and being back on the couch to watch TV is one TV commercial. Wired connections are not without their issues. One, they're not mobile. Unless you want to have a really long cable coming out the back of your car, you're probably not going to drive around the neighborhood, let alone the city, with a wired connection. The second part is the demarcation point. And that's where the technology comes into your building. In many cases, it's in a basement or in a closet somewhere, and you're now responsible for getting that coverage, in this case, the lines, throughout the building. So it's a very expensive install to do locally, and in many cases, it can be an expensive install to have done by your telecom company as well. The final thing is, although most lines are buried, they are prone to damage when it comes to things like construction accidents. So if the site requires high availability, you may have to factor in a redundant connection as well. Wired connections are generally ideal for places that are already pre-wired. So if an office building already was set up for an Ethernet network, it's pretty easy to use at that point. But that's becoming less and less in many places now. The second kind of connectivity is one that most of us use on a daily basis, and that's Wi-Fi. It's most often used when products are connected by the user to a network. So this is very commonly used in applications and in devices that are used in homes and in offices because these devices are going to be connected by the customer. And more often than not, there's a strong motivation for the customer to do that. So the connectivity takes care of itself. The other advantage to Wi-Fi, assuming the customer wants to actually connect the device, is that it offers low-cost connectivity. And that's both for the hardware itself. A Wi-Fi module is one of the cheaper products out there in this space, but also the fact that most Wi-Fi networks are backhauled using wired infrastructure today. So there really isn't much concern about usage. So Wi-Fi can be excellent for things like video monitoring. Its plus is also its negative. It relies on the customer to set up the device. If having Wi-Fi connectivity is part of the overall appeal for the device, then great, the customer is going to connect and maintain that connection for you. But if you're looking to get information from the device and the customer doesn't see a lot of benefit from the Wi-Fi connection, there's a good chance they will not connect it. The other part is that Wi-Fi, although it seems like it's ubiquitous everywhere you go, it's not available everywhere, and it's definitely not ideal for mobile-based applications. The next two issues can be varied based on how the network is set up. Wi-Fi networks do see a huge variation in the speed that is available based on the signal strength. So if you're sitting right next to your Wi-Fi hotspot, you're going to have maximum speed and latency. But when you get a little further out, you definitely see speeds degrade quite quickly. The last issue is security. Wi-Fi networks are secure. It's just that not everyone enables the security by default. So depending on what the security level is for your device, you may be putting your device onto a network that's not secure. The third technology is one that some of you might be saying, what did he just say? Because you might not have heard of Sigfox. And to be honest, if I wasn't so heavily involved in the world of IoT, I'm not sure that I would have either. Sigfox is one of those technologies which seems to be polarizing. A lot of people totally believe in its benefits, and other ones have major issues with it. So I'm going to try to walk the middle and cover it with an unbiased view. What Sigfox is a dedicated IoT network that is optimized for very, very small packets of data going back and forth. Think text message size amounts of information, which may appeal to many people because if all you're looking for is basic daily status reports, there are millions, if not billions, of devices that could definitely use Sigfox. Its appeal is going to be mostly for the fixed assets, ones that are not moving, or if they are moved, are only tracked once they stop moving. And it's also ideal for infrequent transmissions, say once a day type scenario. I'll give you one example of a customer I had heard that used Sigfox, and this was for construction sites. Everyone monitors the big pieces of equipment. They're multi-millions of dollars, and it makes a lot of sense. And they also will monitor some heavy tools using technology like Bluetooth and RFID. But who thinks to monitor the fencing that goes around a construction site? Who monitors if it's been moved? These things don't have a battery on them, and they're generally considered to be dumb devices. By having technology on board that's low cost, you're able to actually justify putting a tracking device on each piece of fence. So now you can be told if the fence moves right away. The other usage case at a construction site, which some might chuckle about, is the porta potties, or Johnny on the spots, as they're nicknamed. Because these things tend to run out of different supplies, maybe they get full, maybe they even get tipped over. Again, there's no battery on these things. So what you needed was a very, very low-cost tracking device with a long-life battery. And that's what Sigfox does offer. It's ideal for mobile-originated traffic, so it's best if the end device, like the porta potty, initiates the conversation. It sounds great. Why isn't everyone using Sigfox? There's a few drawbacks. One, it's mostly availability as the main one. Some areas of the world are completely blanketed with Sigfox coverage, and that's great. However, many areas, including big pockets of North America, have sparse or even no coverage. So, assuming you have coverage, it's best to consider Sigfox for remote monitoring, especially for applications that are long life, where you're looking to deploy the minimum amount of battery to each site. The last thing it does, potentially, as I mentioned with that fence, is to bring into play assets that it never made financial sense to monitor in the past. So Sigfox, if it's available, might actually push IoT into brand new areas that was never considered in the past. The last non-cellular technology we're going to talk about is LoRa, which is long range. So it's LoRa, but there's different variations of capitals on the letters. LoRa is a wide area network that is very optimized for connecting a lot of IoT devices in one geographic space. One key differentiator for LoRa over other technologies we're talking about today is that it's actually available as a shared public network if it's available in your area, and we'll talk about that in a sec, but it's mostly been deployed by a lot of places as a private network. And this is especially true when it comes to cities and municipalities, and we'll cover that in a second. It offers a lot of strong features, more than I actually was aware of before I did some research. The first is its long range, so it can go very far from a tower, which means that you only need a few towers to cover most major cities. The second is based on its low power. That allows for two things. One, batteries last a lot longer, and two, it allows you to make devices a lot cheaper. So you have much lower cost devices available. It's not a speedster. Don't expect to browse a video on these things. It's a little faster than Sigfox, but it's along the same lines of it's meant for tracking devices that don't send a lot of data. One rather interesting feature about LoRa is that some big boy companies are behind this technology, including Cisco and IBM. So that should help to propel its life while it goes through its growing stages. I couldn't find too much on security, but it did look like it had a decent level of security for assets that are a little more vulnerable for attacks. For devices that need more speed, and for those that do not enjoy longer latencies, it might not be the best option. In those cases, you're probably better off looking at some of the cellular options that we're going to talk about after the break. But if it's a low bandwidth application for fixed assets, it might be tough to beat. Where I really see it standing out is for municipalities. So where I'm based in the city of Calgary, Calgary has actually deployed a LoRa-based network, and it looks like they're putting all of their assets over time on it. Because these assets are valuable in terms of the data they report, but not always valuable in terms of the overall cost, it makes sense for the city to put in a low-cost solution to track them. In terms of a public network, it's definitely not available in as many places as cellular networks. However, what I could find is that the LoRa coverage available from providers is expanding pretty quickly, perhaps not as fast as everyone would like, but it definitely is improving. So it's now become a serious threat in the space of IoT. When we come back from the break, we're going to cover 5 different cellular-based options. Used to be just 1 or 2, but there's now 5 different networks that you could put IoT devices on, and we're going to help you walk through that. Back in 5 seconds. In terms of cellular options, what I decided to do was to walk through from the fastest networks to the slowest. It has nothing to do with the quality of network. I just needed a way to get through them, and I thought this kind of made sense. So we're going to start with a network that's not quite available yet, and that's 5G. This one is the Formula One of IoT networks. To call it fast would be an understatement. It's going to offer speeds that exceed what's available for most landline connections. And although it's not quite real time, I was quite surprised to see how low latency it was. It gets about as close to real time as we've ever seen in cellular. So unless you're so concerned about latency, it probably could replace most landline connections for many customers. Its availability seems to change by the hour. There are some test sites that are definitely up, and some areas of the world might have some coverage of 5G, but it's just that. It's test sites for the most part. There aren't really any commercial devices available from the manufacturers. Do expect smartphones to move very fast into the world of 5G. 5G deployments are spearheading what's called massive IoT, which will allow other technologies that we're going to cover in a little bit to be deployed in the kind of spaces with the kind of numbers that totally boggle my mind. I've actually read that as many as 1 million devices could be provided connectivity using 5G-based technologies per square mile, and that's incredible. I haven't actually seen the prices for 5G technology devices, but it won't be cheap. It's going to be the Cadillac in terms of pricing of all hardware available for cellular technology. It's also going to be among the highest power use because all this horsepower needs a pretty big engine. That's going to definitely narrow down the appeal of 5G to people that can truly benefit from the speed, but equally important is the lower latency that 5G provides. One application which isn't being talked about because it might actually hurt the same carriers who are deploying it is that it could replace most DSL and cable in homes and businesses. And the person could then just take it with them to the cottage, for instance. So there's a lot of plus side to using 5G technology, and I'm not quite sure how that's going to shake out. The next one are applications that are truly real-time in nature. If you look at the proverbial mobile surgery, where a surgeon might move a piece of equipment and it will move on the other end, obviously any kind of delays in connectivity is going to cause issues. So I think you're going to start to see those applications move towards 5G for sure. The last one is in self-driving cars, and it kind of makes sense to me they're going to use 5G because they're not really worried about power consumption. It's not like the cellular module would be the part on the car that would use the most power. They're also not likely worried about cost because a cell module will be a fraction of the overall bill of materials for the average vehicle. So I expect 5G to be aimed at the premium level of the market. But it might not be as much of an IoT draw as some people might think. The second technology is what most of us use today, and that's 4G LTE-based technology. It is the current king for speed, and it is the network that most smartphones are using today. Its benefits are quite compelling. One, it's proven, it's reliable, and it's available in most urban areas and in many rural areas as well. It has the current lowest latency offered, although as I mentioned, 5G does go lower. And there's also a really wide availability of products, ranging from modules to finished products. They're all available today. For the most part, it fills the need if you have the need for speed. Now try saying that 5 times fast. 4G offers enough speeds that most of us never go near its capacity anyways. It allows for real-time video and allows for many real-time applications, so many people won't need to go to 5G. They might want to, just to be on the latest and greatest, but I'm not sure they necessarily need to. 4G has always had some drawbacks when it comes to IoT. The first was cost. The cost of components is always higher than the slower technologies. And the second was power consumption. And that's fine, again, if you're using it in a car, but if you're using it in a tracking device where battery power is at a premium, you're going to want to reduce the technology speeds down, and 4G was never ideal for that. But it was the perfect technology for most routers and gateways. And most modems sold today use 4G technology. It's fine for what's called infotainment for vehicles, things like browsing in the car and getting information from Yelp, those kind of things. And it offered a perfect technology for landline replacement, especially if the site happened to move around once in a while. It's going to lose some of its thunder when 5G comes out, But based on what I've seen, the cost difference between 5G and 4G hardware, I think 4G's got a lot of life left in it. The next technology is one that some of you might not have heard of, and it's called Cat 1. And it would be what I call the Goldilocks of IoT technologies. It's got some speed, but it's definitely not fast. It's lower in power use than other devices, but it's definitely not as good as some of the other networks I'm going to talk about. It definitely offers decent throughput speeds, and that makes it the lowest cellular option for doing some real-time applications. It's also the lowest cost technology that fully supports two-way voice traffic. The components are less complex and therefore less expensive and draw less power than what traditional 4G technology products do. The network is available in most areas, and there's a decent selection of hardware available. Not nearly as much as 4G, but you can definitely find what you need. I think Cat 1 is kind of ideal for applications that really need a real-time connectivity with decently low latency, but don't always need that speed. So if you take as an example a digital sign, it might just need basic monitoring most of the time, and then at 2 o'clock in the morning, it will download all of its video content for the day. That sounds like a great application for Cat 1. Sure, it's not quite as quick as 4G, but at 2 o'clock in the morning, if the content takes an extra minute or two behind the scenes, what does that matter? The same goes for things like kiosks and point-of-sale terminals, lottery machines, and even some of the fixed healthcare machines like MRI devices in hospitals. I think these things will do quite well with Cat 1. Where it's not ideal is what I call if you need better. If you need better speed, then you're going to opt for 4G or even 5G. If you need better latency, you're going to opt for one of those networks. And if you need better battery life, you're going to go for one of the technologies that I'm going to speak about after the break. Those are going to be a little better. But if you're okay with the Goldilocks, I think Cat 1 is definitely an overlooked technology. When we come back from a short break, we're going to slow things down by talking about two networks that definitely do not feel the need for speed. Back in a few seconds. The next technology we're going to speak about is Cat M, as in Michael. It was described from what I could see on the internet as being the slowest of the medium-rate IoT technologies. I think that might be actually giving a little more credit. To me, it's the faster of the slow technologies, because there's a considerable drop in speed between Cat M and other technologies. It also comes with some other limitations. It does support voice traffic, but it tends to be in only one-way traffic, so like a walkie-talkie type scenario. It can be used in a mobile environment, but you may want to make sure that comes with an asterisk, because there are some issues. I won't go into it in this podcast because it gets pretty nerdy, but if you're looking at deploying Cat M in a mobile technology, make sure you do your research. It probably is still the ideal technology, but it doesn't come without its downfalls. It is considered to be a low power network when it comes to battery usage, and for many applications, which we're going to go into in a second, it will function quite well on a battery. Like 5G, its availability seems to change every hour. There's a press release coming out, it seems like every day, with a carrier talking about Cat M, and they don't really specify exactly when the networks are going to roll out. Because the network uses the same infrastructure as LTE, there isn't much work to be done by the carriers compared to other technologies, so the rollout should be quite quick, and you will see some networks deployed in 2018 and much more in 2019. In many applications, it might offer just enough speed for things that are transmitting more than text. This is definitely not a choice for video, but if you're doing a firmware update once a month or twice a year, you might get away with Cat M and just know it's going to take a little longer to push the firmware update out. But if you're looking for anything that needs bursts of speeds, you might want to look elsewhere. We're going to talk about NB1 next, and Cat M does offer advantages in this lower speed segment in that it is faster than NB1, and it does offer the ability to do some mobile work, as I mentioned. If you don't need those two things, then the advantage for Cat M over NB1 does start to fall down a little bit. Where I see it being used is in three main areas. The first space that will definitely use Cat-M is in the health sector. And that's things like wearables and patient trackers, namely, but it could also be used in some of the blood pressure cuffs, depending on how much data needs to be sent. It should be the go-to technology for a lot of tracking devices. Again, do your research. And the same goes for some of the mobile telematics apps that are used. So in the event of looking after where a vehicle is and being able to get some information, Cat-M should play quite well in that space. The last technology, and this would be the snail of the group, would be NB1. And I don't want to knock it because sometimes you don't need speed. And that's why NB1 could end up being the one that has the most devices on it when it's all said and done. The slow transmission speed does mean that devices on this network use less power than any other cellular technology. Not quite in the Sigfox space, but somewhere in the ballpark from what I can understand. The details on the availability of NB1 are a bit more sketchy. It looks like we're going to see some deployments in limited spaces in 2018, definitely more in 2019, so be sure to watch the press releases from your favorite provider. In order to truly benefit from using NB1, your application must not need these two things. The first is speed. It's not going to get there fast. Think of it as the ground delivery option. It'll get there eventually. It will take a little longer. But if you don't need it to get there fast, why would you pay for air delivery? And in this case, why would you pay for more speed than NB1? The second thing you must not need is low latency, because NB1 is definitely a high latency network. There is no way if your application needs anywhere close to real time for you to consider using NB1. It's also not optimized for mobile traffic. So you want to put it in things that you set it and forget it, that they don't move. Its applications are so widespread though. Here's a few examples. If you had a lighting control system, say for floodlights at a baseball diamond, NB1 is definitely an option. So is Sigfox, but it would be the cellular-based option. It's also going to apply to things like industrial SCADA. So if it's an oil well out in the field that just needs to report some basic information, NB1 might actually be the optimal choice. I see it used a lot in monitoring applications, and that could be things like HVAC systems and other devices. I hope you enjoyed this podcast. Our goal is to try to keep them simple, and hopefully it's one that you enjoy. As I mentioned before, I very humbly ask that you review our current webpage, theinternetofThingsmadesimple.com, and that you subscribe to this podcast using whatever service you use. I'm Leonard Bohumer. Thanks for listening.